Vern, Aaron, Sarada, come on up if you hear me. Yeah, welcome them up. First, we have Dr. Aaron Davis, who is Senior Research Leader of Crops and Global Change at the Royal Botanic Gardens, Kew, in the UK. Many of you know him by reputation. He is unquestionably the world's leading authority on coffee species. He has traveled all over Africa and Madagascar to study coffee plants in the wild and to study their uses in cultivation. And he publishes widely on coffee. He is also doing a lot of work right now, and we're going to hear about some of it, on the use and development of wild or underutilized coffee species, particularly within the context of climate change adaptation. We have also with us Dr. Sarada Krishnan, who is maybe second only to Aaron in the world in terms of knowledge of wild coffee species. She's the executive director of the International Women's Coffee Alliance. She also serves as the director of horticulture and the Center for Global Initiatives at the Denver Botanic Gardens. And she soon will be moving to Bonn, Germany, to become the director of projects at the Global Crop Diversity Trust, also known as Crop Trust, which is very, very good for coffee. She has a degree in horticulture, and she wrote her dissertation on the conservation of genetics of wild coffee in Madagascar, which contains like almost half of the known wild coffee species in the world on this one little island. So very cool stuff. And coffee's been a part of her life for her entire life. She grew up on coffee plantations or working, her family had coffee plantations in India, and she owns now coffee plantations in Jamaica. We also have Vern Long, my boss. Vern is the Chief Executive Officer of World Coffee Research, the world's first global industry-driven collaborative agricultural R&D organization for coffee. She's a plant breeder by training and brings decades of experience in international agricultural research with a focus on building collaborations between industry, government, and research institutions. She received her PhD in plant breeding from Cornell University. And we also have joining us virtually live, we hope the connections all work. Thank you, SCA, for trying to really, really make a difficult situation better. Dr. Catherine Kikua, who was supposed to be here with us in person, but her visa did not come through in time. Dr. Kikua is an in situ conservationist with Uganda's National Agricultural Research Organization, NARO. She's based in the Plant Genetic Resources Center, and she has been working on projects to secure plant genetic resources and explore their potential and use in ways that contribute to livelihood needs in Uganda. So please join me in welcoming our panelists.
Good morning, everybody. Thanks for a wonderful introduction to this session. We couldn't have wished for a better introduction. As Hannah said, my name is Dr. Aaron Davis. I'm leader of Crops and Global Change at the Royal Botanic Gardens, Kew, but my research focus is coffee. And I've been doing that for the last 20 years or so. I must say it's wonderful to be back in Boston talking about species 10 years later and not talking about climate change, which nobody wants to hear about. And yeah, it's just not fun to talk about climate change. So the title of this session is The Future of Wild Coffee Species in Our Cup. I think it's a very apt title for this session. As Hannah said, we drink two species, Arabica and robusta, and yet in the wild, in the old world, there are another 128 species known to science, and that number will increase slightly over the coming years. The main diversity of those species is in Africa and Madagascar, and particularly Madagascar, which holds half the world's coffee species. Now, this is a summary. I usually end a talk with a summary, but I'm going to start very much with a summary. And I'm going to look at 5, what I believe are key points regarding the future of wild coffee species. And I said I wasn't going to talk about climate change, but for me, that is the main point. We need to adapt to climate change. That is absolutely essential. We also need to adapt to emerging pest and disease problems, but I'm not going to mention that so much today. Now, the harsh reality, I think, is that we've relied on 2 species to provide us with the bulk of the coffee that we consume over the last 400 years, and they've served us incredibly well for that purpose. The game changer, of course, is climate change. If we were to be having this conversation in Boston 10 years ago, we would have perhaps been thinking that Arabica had some potential in its wild gene pool to overcome some of the issues of climate change, and that robusta would replace Arabica when Arabica failed. But I'm afraid the bad news is that's not going to happen. Now, I'm not saying we shouldn't invest in the development of robusta and Arabica. Absolutely not. I'm not saying that. What I am saying is that we need to broaden the crop portfolio for coffee if we're interested in long-term sustainability. If we were to go back 150 years, we would be drinking more coffee species than we do today. Anyway, where would we start looking? There's 128 other species. Where would we start looking amongst that species pool for the solutions that we require? Well, I believe we should look at the species that are either already cultivated or once cultivated. So I have a list here of 9 taxa, 8 species, including Arabica and robusta. And those species are the ones that are cultivated at least at some scale, or will be cultivated at some scale in the coming years. Now, it was interesting going back to the Boston, what I didn't anticipate during that session was that the interest people had. What do they taste like? How do they grow? What do they look like? And as Hannah said, there was this journey by people other than myself looking at wild coffee species. But for us, the single most important priority species was Stenophylla coffee. Why? Because it's said to have a taste that is as good as Arabica. It has a superior flavor. And reports in the early 1900s, the early 19th century, were saying that actually the taste of Stenophylla surpasses Arabica, which is very provocative to somebody like myself. In the end of 2018, we managed to relocate Stenophylla, wild populations of Stenophylla in Sierra Leone, but it wasn't until 2020 that we had sufficient cupping samples to do a proper evaluation. One from the wild and one from a cultivated source. Now, Stenophylla had not been assessed for its sensory potential in over 120 years. So this was quite exciting. And we had a real surprise. Our best sort of hope that it would be okay, average, not awful. In fact, it surprised us by tasting really rather good. In fact, our first cupping, we had a very small sample, just 9 grams, and that sample tasted like a high elevation Rwandan Arabica, which just kind of really blew us all away. So I've talked a little about climate change. I've talked about broadening the flavor profile in the example of Stenophylla. I think the key thing with Stenophylla is that what we said in the paper is that it was Arabica-like, not Arabica. So it is different. So it does have the potential to broaden the portfolio. Looking across those other priority species, what you see, in fact, is that over the last few years that there has been a few upstarts, some other species that have come in to the present definition of specialty coffee. That's Eugenioides and Stenophylla. Looking at this list, I think Liberica is nudging the upper 70s, possibly into the lower 80s, and some of you may already be growing specialty Libericas. Now, a lot of those species, and there's another 30 wild species which are yet untapped for their potential, do have the potential for small-scale production. But that's not enough. We don't need bags, we need containers. We need hundreds of containers to make up the shortfall that we will experience. So we need crops that can fulfill the specialty niche market and the commodity market, whether that's specialty or just plain commodity. And I believe that Arabica coffee is one of the priority or the main priority species in that regard at the moment. Here is a picture on the left of Catherine Chiwuka, who will be talking later, and she is holding down a branch of Arabica coffee. On the right is a large dry sack full of Excelsa cherry. That's the other type of Arabica coffee. That is a bag of coffee from one tree, 40, maybe 50 kgs of fresh cherry from one tree. There is a tree that we visited in Uganda that produces 300 kgs of cherry. It's enormous. 10 of us could stand underneath, no problem. There is huge variation in Arabica coffee. Here's Catherine's hand holding two samples. On the left is the Arabica coffee from West Africa. The fruits are about the size of walnuts. And on the other side is Excelsa coffee, where the fruits are a little bit bigger than, say, Arabica. The fruits are slightly smaller, roughly the same size. So a considerable amount of variation. So there we have coffees, some coffees with potential. What I failed to tell you was that I talked about the sensory angle on Stenophylla, but one of the most important things is its heat tolerance. So it will produce an Arabican-like coffee under a climate with an average mean temperature that's nearly 7 degrees higher than Arabica. What does that mean? It means you can grow an Arabica-like coffee in robusta-like conditions. So it's a low elevation coffee with a high elevation flavor profile. If we're going forward, towards the end of the century, perhaps even the mid part of the century, we're going to need some pretty drastic climate change resiliency solutions. And we're going to need to develop a completely new generation of crops. And to do that, we will need plant breeding and or gene editing. We will need to do something quite substantial. Let's look at the example of Ibu coffee. This is northern Mozambique on Carimbas Islands in the Carimbas archipelago. This is a very hot, seasonally dry island. None of the coffees I would mention would survive here more than a few days without water. If you were to turn around on that beach, you'd see coffee drying, being processed on the beach. If you go a little bit further inland, you will find production coffee. And this is Ibu coffee. This crops not in 9 months like Arabica, but 3 to 4 months. It requires half the rainfall and will grow in temperatures in excess of 35 degrees C, probably even up to 40 degrees C on some days. It's deciduous, so it can withstand a long dry season. I think it's attributes like this that are going to be required to produce our next generation coffees. And to do that, will require the use of plant breeding or gene editing or both. The problem with this coffee is the beans are very small and the flavors are somewhat challenging. You'll find out in a little while. Ibu coffee is very similar. It's actually a sister species to Racemosa coffee. But I would also say it can taste really rather interesting. So all of this is only possible, as Hannah says, if we have the genetic diversity at hand, if it's available. Conservation is going to be essential. Conservation of these key resources will be absolutely essential. We did an IUCN Red List assessment for all of those coffee species, well, 124 actually at the time, and what we found was that 60% of all wild coffee species are threatened with extinction. 60%. If we had waited another 10 years to find Stenophylla in Sierra Leone, I'm pretty sure it wouldn't have been there. As we lose each species, we lose an option for resiliency. Our cultivated species come from the wild. That's what, it's as simple as that. And our future in coffee will be from those wild coffee resources.
Good morning, everyone. I'm Sharada Krishnan, and with the Denver Botanic Gardens, and Hannah gave the introduction. And thanks, Aaron. Aaron gave a wonderful summary of the status of coffee and the different species with a lead-in into why conservation is needed. So I'm going to reiterate the importance of conservation of all the different coffee species. So if we look at our human history and how agriculture has evolved, we rely on the wild cousins of many of our crops, and we call them the crop wild relatives. So when domestication of plants, our crops happened, our ancestors relied on these wild species, and through natural selection, they have developed our current crops. A perfect example is the corn or maize, where the wild species is the teosinte, which is found in central Mexico. And through the domestication of that one plant, it has led to the development of corn or maize as we know it today, and one of the most highest producing crop in the world. So the wild cousins, they have all of these resiliency to climate adaptation, pest and disease tolerance that we have not tapped into. So when we look at conserving to making our crops resilient, we really need to look at their wild cousins to look for those resilient genes that we can incorporate into our crops through plant breeding and also with selection. And coffee is no different. So coffee has that 130 species of Coffea, and so we need to really look into the coffee species also. Within the coffee genus, the species, there is high diversity with 130 species. But the cultivated Coffea Arabica has very low genetic diversity. And because we have relied on just two lineages, the Typica and the Bourbon lineages, for our cultivation of Arabica coffee. And this has led to a bottleneck in genetic diversity, which leads to, with low genetic diversity, they are highly susceptible to pests, diseases, and they do not have any climate adaptation. And a perfect example is the spread of coffee leaf rust. Coffee leaf rust spread from its center of origin in Ethiopia to Sri Lanka, at that time Ceylon, in 1868, and from there to India in 1869. And since then, coffee leaf rust has spread all around the world. And it is one of the most devastating diseases economically and socially. It is one of the greatest diseases. And since the spread in the 1800s, the researchers have been looking for ways to develop resistance in a cultivated coffee to this coffee leaf rust. And so what happened, that led, as they were looking, we talked about Robusta, the spread of Robusta. In the 1900s, Robusta showed resistance to coffee leaf rust. So as an alternate coffee crop, Robusta was spread around the world. But in addition to Robusta, there are so many other species that we have not tapped into. And we don't even know what traits they have that can confer resilience to our cultivated coffee. So we need to start utilizing the species diversity. And there are examples. There have been hybridization with Coffea between species that have happened that have conferred resilience. And a perfect example is the hybrid of Timor that happened. It is a natural cross that happened between Coffea arabica and Coffea canephora in the island of Timor in the 1920s. And since then, Timor hybrid has spread all over the world and has been the major source of coffee leaf rust resistance in most breeding programs. And the Timor hybrid, you see the Katimor, Sarchimor, any of that end with the more have parentage with the hybrid of Timor. And also there have been spontaneous crosses between Coffea arabica and Coffea liberica in India that have been the source of breeding programs for coffee leaf rust resistance in India. And so we'll have at the tasting today, we'll have a little Coffea liberica from India that you would get to taste. And so Hannah explained what in situ conservation and ex situ conservation is. So in order to protect these species, and a lot of them are threatened with extinction, we need to look at two ways of conserving them, either in situ in their natural habitats, or XC2 in field gene banks. So that is why, in order to develop, ensure that they are conserved, the World Coffee Research and the Crop Trust developed the Global Coffee Conservation Strategy in 2016-2017, and it identifies 6 high-priority action items that provide a roadmap for us to conserve these species to ensure the future of coffee.
So thank you to Sharada and to Aaron to really set the stage on not only the urgency of this situation, but the tremendous possibility and hope that this brings for us as an industry, looking forward to the future, the next 20, 30, 50, and 100 years. Where is our industry going to go, and what are we going to need, what do we need to do now to assure the continued long-term stability and opportunity that our industry brings both to those who are producers and all of the thriving businesses around the world that rely on this amazing crop? So what I'm going to just tag onto just a bit, and then we'll really dive in more deeply and richly in the discussion, is to talk about bringing this together from a policy standpoint. And that is, we know this image of the world from an imperial map looking at the trade routes of the colonial powers. Hannah walked us through that narrative of the historical trade and movement of plant species around the world in the last hundreds of years. And the reality remains that ethos of the free movement of material really led in the early 20th century to a concept of plant genetic resources or plant varieties and plant species as being a common heritage of humanity that were to be widely shared and conserved and move freely across borders to bring the opportunity that potatoes from the Western Hemisphere brought to Ireland became a staple in the culture and the diet. Tomatoes in Italy, can we imagine Italian food without tomatoes? Yet those are Western Hemisphere crops. So that movement of crops around the world has been really important in redefining and innovating new foods and new cultural experiences. And that common heritage of humanity was something that really pervaded the exchange of plant genetic resources. In the early 1990s, there was a confluence of factors that came together around intellectual property rights, sovereign rights over national resources, and this conversation has really shifted. So when we think about the opportunity out there for producing countries and for the producing community at large at a global scale, and what the industry, the consuming countries are really interested in exploring new flavors, new experiences, even if they may be challenging. We may find new tastes that we get really excited about that we've never imagined before and we'll start craving. So there's a tremendous amount of opportunity. But to harness that opportunity, we just really need to understand the rules of engagement. And since 1993, with the advent of the Convention on Biological Diversity, there was a global consensus that countries have the rights to protect their sovereign rights over their genetic resources, which has upended this historical approach to movement of material freely and smoothly across borders. And so it's just, I feel, the point I want to bring into the conversation as we go to the Q&A and the discussion is really to understand that the world has changed from the way it was over the last hundreds of years where plant materials move freely to a time where we really think very carefully about how can we ensure that the sovereign rights of countries are protected in alignment with global policy frameworks. So the Nagoya Protocol is an agreement that was taken that really brought the international community together to clarify that genetic resources or germplasm, and when we're talking about our seeds or plant material, a leaf, those are the sovereign rights of individual countries. And so as we think about mobilizing and using those genetic resources, we need to understand that there are rules about the movement of material across borders. You do need permits. You do need to get permissions and enter into agreements often that involve benefit sharing. So the transfer of resources and benefits to those who are the providers and those who are seeking to access the material. So we'll talk a bit more about this, but I'm going to now transition to Catherine's video. Unfortunately, she couldn't join us here in Boston, but she's going to start talking about this tremendous, amazing resources that are in Uganda that really are an example of this tremendous opportunity for Ugandan growers to take advantage of their own natural resources to really create something new and exciting, both for producers who are interested in meeting opportunities in world markets and us as an industry who are really interested in bringing those opportunities to the world, to the consumers. So I'm going to turn it over to Hannah, who will hopefully help us get to Catherine.
Hello. It's a pleasure to share with you our efforts and experiences in exploring coffee natural capital in Uganda, and also working with a set of communities to see how this diversity can sustain livelihoods in conditions where climate change is challenging production and productivity of the commodity. These are efforts financially supported by the Darwin Initiative and a team of researchers from National Agricultural Research Organization, Makerere University, Chagalani Coffee, Clifton Coffee Roasters, and the Royal Botanic Gardens of Kew are implementing the project activities. Why coffee? We all know the importance of coffee, but most especially for us, Uganda, coffee is a very important commodity. It has sustained livelihoods of Ugandans for over 7 decades, and it's a commodity sustaining over 8 million Ugandans across the whole value chain. Uganda is the second largest producer of coffee when you combine robusta and Arabica. But as climate change sets in, there are challenges that arise due to variations in precipitation, temperature, and also pest and disease pressures. But amidst all those challenges, there is hope because we have diverse coffee genetic resources thriving in natural habitats, most especially forest reserves of Uganda. And within those forest reserves, you find 3 important species: Coffea canephora, Coffea ignoides, and Coffea Arabica, thriving in protected areas occurring in different climatic conditions, and their existence in conditions that are varying in terms of climatic zones is of great value to the sustainability of the coffee sector, because as material continues to thrive in the wild, it adapts to the challenges within its local environment, and by adapting, we can use that material to confer resilience to the cultivated material. A team of researchers collected genetic resources from Zolka, Itwara, Kibale, and all these forests are occurring in different agroecological zones of Uganda. Excelsa coffee. This Excelsa coffee is quite interesting in the Ugandan setting. There is a team of farmers in Luwero, Zirogwe, in Luwero district, Zirogwe. These farmers have been growing, intentionally growing and trading this coffee for over 4 decades. It has some unique sweetness, and us as researchers, we're working with these farmers to streamline the market and create a global market niche for this Excelsa coffee. It's currently showing potential in its cup quality. There's amazing variation, which we are going to understand which variation gives the best cup quality, the best climatic resilience. And working with the Chagalani Coffee and Clifton Coffee Roasters, we want to see how best to create a distinct market niche for this coffee, Arabica coffee, Excelsa coffee. Uganda, as I mentioned, is a center of diversity for 3 species, and it's quite interesting that 2 parents of Coffea Arabica coexist in Uganda's natural forest. Here you see a researcher standing next to Coffea canifera, robusta coffee, and Coffea ignoides. Coffea ignoides is quite interesting too because it has a low caffeine content and it has incredible sweetness. But because of our limited understanding of its agronomic requirements, its benefits have not been utilized or optimized. So in this project, we are working to understand the agronomic potential of ignoides coffee, of Coffea ignoides, and we have collected seedlings, we bred seedlings from stem cuttings, seedlings, to establish them purposely to use them as planting material for trial plots that will be established in different agroecological zones, basically to understand the agronomic potential of Coffea ignoides, Coffea liberica, and also to assess the climate resilience of these species across those agroecological zones. And what we've done is to use scientific methods to understand this as a way of creating empirical data that will support our efforts in lobbying for an accepted commodity with acceptable cup qualities and acceptable traits for climate resilience. We established field plots in contrasting agroecological zones, and in each field we installed climate stations basically to understand and keep track of the variations in environmental variables like precipitation, soil moisture, temperature, and also link that to the performance of the species as a way of clearly understanding how the species perform across the agroecological zones. By doing that, we are not only focusing on the performance, but also on the cup quality. We want to see how the cup quality issues vary across the environmental conditions or across the contrasting agroecological zones. By doing that, and as climate change sets in and as the coffee industry evolves, we need to be ready to provide consumers with species of accepted or of acceptable cup quality traits, of acceptable farmers to provide also farmers with material that can be grown in these challenging environmental conditions. I thank you for listening and supporting these initiatives.
All right. So we're gonna have a little conversation now about wild coffee and go a little bit deeper on some of these subjects. And I hope that we may have Catherine joining us virtually. There she is. Oh, yay, technology. I can't believe the world we live in. Hi, Catherine.
Hi, Anna, how are you?
We're so good. It's so nice to see you. Let me start with you. I have a follow-up question for you. I want to ask you a question about trade-offs. I have this story in my head that one of the reasons why Arabica and robusta are the sort of dominant species that we grow and consume right now is because they're easier to grow, that they produce more coffee, farmers are able to make a good livelihood with them. I actually don't know if that's a true story or not. And so I'm curious, based on your experience working with Ugandan growers growing Liberica, many of them who have been growing it, as you said, for 4 decades, how is the plant itself different from Arabica and robusta, and what traits does it have that farmers like? Why are farmers choosing to grow Liberica over these other species? Yeah. Could you talk just a little bit about trade-offs? How do farmers make these choices?
Thank you so much, Hannah. Farmers really weigh options available. In Uganda, our agriculture system, or the coffee farming system, is basically rain-fed. We are at about 0.1% irrigation potential. But as farmers navigate through their production system, they choose. For instance, Coffea liberica, farmers intentionally picked this wild species from forests and started their own plots without any government initiative, and they've continuously grown this basically because of its vigor. It is high yielding, about 300 kilograms per tree. It is robust in the sense that it's resilient to most pests and diseases, and also it's seemingly being recognized as a drought-tolerant species. So as farmers navigate through, or as they weigh options of irrigation, options of climate change challenges, they find that this species surpasses all the agronomic requirements of Arabica and Carnivora. Arabica and robusta. And probably to also highlight, I mean, we have limitation. There is a lot of potential in the wild coffee species, but because research and also our focus is on these two species, it limits us from identifying the potential within other species. So it's not like, I don't want really to say, given the fact that I have a bias towards diversity and the potential there is, our limited knowledge of what exists and the potential there is makes us focus on only these two species.
Thank you, Catherine. That's wonderful. Well, Aaron, maybe you can pick it up from there. There are some species that we might consider wild in the sense that we haven't really heard much about them before. Can you talk to us a little bit about the state of cultivation of these alternative species? Like how much is actually going on out there? Where is Liberica and Eugenioides being grown, and Stenophylla, the paper that you published recently? Can you just kind of paint a picture of the landscape for us?
Yeah, I'll do my best. So, I think in some cases there's a necessity to swap out. And we've heard from Catherine, the farmers in Uganda are swapping out robusta for liberica. It's their decision. I think that's really quite an interesting situation to be in. It's not by any means unique. It's happened in the past, including Uganda, where they were told to grow Arabica and went ahead and grew robusta. But I think it will come down to economics. Will people be able to make money? Individual estates, or communities, or cooperatives. It has to be economically viable. And I see there's a question here. And it has to be taken to scale. So some of these coffees, I think because of their inherent physical characteristics, will always be niche, and will always be high value, and will always be sought after because they're low production volume. But we have to go to scale, and it has to enter into the commodity scale of things. Containers, hundreds of containers, not bags or hundreds of bags. I think that's absolutely clear. And I see it already happening. So with the case of Liberica and Excelsa, there's been a huge amount of interest in the roasting and the barista community in the species, but also amongst growers. So what we're seeing in Uganda is very exciting with the Excelsa type of Liberica, but that is being picked up elsewhere, in South Sudan, in West Africa, in Asia. And I think it won't be too long before that happens in the Americas. I think it will happen as these things do happen. Do they need government intervention? In some cases, I think, or bigger scale intervention, then yeah, I think that's absolutely essential.
So that's one way wild coffee species get used, right? So either farmers are sort of selecting them out of the forest, or these programs are put in place to help expand cultivation of the species more or less as they are. The other way that wild species get used is through breeding. So Vern, I wanted to ask you a follow-up question, similar to the question I just asked Aaron. Can you just tell me a little bit more about the state of breeding with wild coffee species, or what we might call wild coffee species? What's sort of going on in the world in terms of this, and what are the challenges?
So first, I'd like to just pick up on what Aaron was talking about, this shift from niche and small batch production to, at scale. And I think that this is where this policy reality comes into play, and it both affects this vision of taking materials. So for instance, if there is a wild species that is from a particular country, in order to move it into production in other countries, there actually needs to be a negotiation with the government, because those materials belong to the origin government. So in order to actually expand scale beyond a particular nation's borders, there has to be a negotiation for the lawful use of those materials outside of the origin country. And I think that is then what brings us to the breeding question, is that even for breeders, whether we're talking about breeding Arabica or breeding with wide crosses, when we talk about maybe crossing an Arabica accession with a wild species to bring in new innovation, as happened with naturally with the spontaneous love affair between robusta and Arabica in East Timor, or in Timor, that wide cross is something that happens very rarely. It does happen, but it brings in that new innovation into the gene pool, so that the materials that are now spreading across the world that are resistant to coffee leaf rust are progeny, the grandchildren and the great-grandchildren of that original cross made in East Timor. So in order for us to take advantage of the amazing features of many of the wild species, either breeding within the species, which is a far easier enterprise, or wide crosses into Arabica to create something completely new. Those are possible, but they also take time. And in addition to time and complexity, there's the legal dimension. So to be able to make crosses with material, unless it's happening in the country of origin, that's the other dimension of this issue, which we didn't contend with in the 60s and 70s, when in 1967 was the last time there was a major global breeding push to bring germplasm into crosses and then distribute it globally. There's a reason why that hasn't happened in the last few decades, and it's largely in part to this new policy world order that we live in, and that affects our ability to do the kinds of crosses, whether it's crossing material and breeding and, the 10, 15-year timelines associated with developing new materials that then can become varieties, or even just moving accessions of, Stenophylla from West Africa to, Mozambique for production. That all requires engaging in this policy landscape. So I'm not answering the breeding question directly, but I will say it takes time. And if we're going to start, we need to start now, because we're dealing with a tree crop, whether it's a wild species or Arabica. We can't wait any longer.
Can I just emphasize that point?
Please do.
So Vern, you're absolutely right, of course. I think the other thing to put into the mix is that crosses between species that are not closely related has already happened. So we have Aramosa, which is Racemosa times Arabica. But as Vern said, that's taken 35 years. We simply don't have 35 years. So we need that technology to make use of those attributes that are going to be so essential going forward.
And just to follow up on that, you used the word technology. What do you mean by that? I'm assuming you're talking about gene editing or modern genetic. Can you talk a little bit about what the role for that might be when we're thinking of wild species?
Yeah, I'm just going to re-emphasize another Vern's point. This is a woody crop, so it takes time to do the breeding. It's not like an annual crop like wheat, where you can do you've got an annual cycle. Cycles are like at least 5, maybe 10 years. There are speed breeding techniques. Breeding technology is moved on. I know genetic modification, gene editing is a dirty word in many circumstances, but the potential there for some quick actions, some quick gains, I think is immense. So there might be species, for example, like Stenophylla, which doesn't have as many fruits as robusta or Arabica, but the shift from few fruits to many fruits is quite possible. It really is doable with gene editing. So I think we'll either see some advances with gene editing or some combination with speed breeding, marker-selected breeding, and gene editing. But we have to, as you say, get going, because we haven't had a lot of movement, I think, in the last 10 years.
Well, just to clarify on terminology for folks, for those who aren't familiar, gene editing is different than what you might think of as traditional genetic modification. It's about taking the existing plant's genetics, and one version of it is knocking out a gene. So you're sort of deleting a gene. You're not taking something from another organism and putting it into. And there are some characteristics of plants that can't be manipulated through gene editing because they're very complex. They involve lots and lots of genes. Cup quality is one of those. Climate resilience is another of those. We're not going to solve those problems with gene editing. But other things like the ability of a plant to produce more fruit or less fruit, or grow tall or grow short, which is a characteristic that helps with harvesting, some of those are controlled by few genes and would be potential targets for gene editing if that were to become possible or palatable.
I think the main thing is the sophistication of gene editing compared to 10, 20 years ago. Before we were just firing DNA at a plant or an organism willy-nilly. Now we can insert, we can delete, we can modify. It's so much more precise, and that is why it's getting traction in terms of policy and acceptance. So now in the EU, in the UK, gene editing is on its way to becoming legalized, for want of a better word. It has moved on substantially in a very short space of time.
It's sort of, I guess, another example of, Kim showed the kind of wave graph, the bridges graph at the beginning of, public opinion is not settled and the world is changing. And so it'll be interesting to see how the conversation around this advances, but clearly it is a technology that's being used in agriculture and other crops. It's not being widely applied in coffee yet, and I think remains to be seen how it will be, but a lot of potential. Sarada, I want to turn to you because this is all nice, this is all lovely conversation to have, but it really doesn't matter if we don't have that genetic diversity conserved. So can you help paint a better picture for us of what is the state of preservation of coffee genetic resources? I gave the analogy earlier of you can think of it like a bank. Is there a roof on the bank? Are there walls? Are there how much rain is coming in? What is the state of the world's gene banks for coffee?
Yeah, thanks, Hannah. And the gene banks typically are in producing countries because that's where they grow in the field. And they're all mainly associated with their ministries of agriculture or their national institutions. But they're all strapped for resources. It's many of the gene banks, the curators are aging and retiring, and there aren't qualified people to replace them. And that is happening in the United States itself. Our national plant germplasm system is also seeing that, where many of our gene bank professionals scientists are retiring, and we don't have qualified individuals to replace them. And then we have infrastructure is old and crumbling. And an example I showed at the 2017 RICO was in Madagascar, the bridge has broken and they don't even have funds to replace the bridge. And also just human capital that you need to maintain these field gene banks. It's not like producing, conserving seeds and putting them away in perpetuity in a seed bank. This one needs care, and so they are exposed to pests and diseases. Mm-hmm. So you need to have constant maintenance, and all of that takes financial resources too. And going back to one about the access and benefit sharing that Vern talked about, the global conservation strategy, when we developed, that was one of the 6 priority items that we identified that we need to look at. How does access and benefit sharing look for coffee? And that is one of the highest priorities that we need to work out before we can start using them in breeding programs.
Yeah. Somebody from the audience has a question about significant risk of new diseases. Is there a risk that new diseases could emerge that could affect existing varieties, including some of these wild varieties. We're talking about these wild varieties as potentially having the potential to address our existing pest and disease challenges, but what about new diseases? I don't know, Aaron, do you want to take that one?
Yeah, for me, in the projects that we run, the key thing I think is zero risk for farmers, whether that's economic, social, or biological. Mm-hmm. So we have to be very careful about issues like introducing pests and diseases. That's absolutely essential, and that's why I think that if you've got something that already has momentum, that the farmer's already finding working, Catherine will be able to elaborate on this, then you're not forcing anything, any decisions or any situations that might be harmful. And we haven't talked about pests and diseases, but it's an absolutely critical component of developing new coffee species, absolutely. And that's what's been so exciting about Uganda. But perhaps Catherine can comment on that.
Mm-hmm. Did you want to add something?
Yeah, I just wanted to add, I think we can take the COVID as a perfect example when we think we are over Omicron and then a new variant comes in. Mm-hmm. And that is the same with coffee. The coffee leaf rust has these virulent genes. The rust itself, the fungus, has certain virulent genes. And as we develop a new variety that is resistant to a certain virulent strain of the fungus, then they become smarter and they develop a newer strain. And so we really need to be one step above this in our breeding program because we are looking at the future. Okay, when will the next new virulent strain come in? So we are just dealing with that as a pandemic now too with COVID.
And, plants aren't.
Yeah,
plants are very similar. Yeah, and so I guess a broader point there too is just it is possible that entirely new diseases and pests could emerge that aren't just new strains of something we've seen before that could affect these plants. And part of the point is that if we don't have genetic resources conserved, we do not have the toolbox that we may need to deal with them. If those plants are gone, they're gone forever, and we can't just invent the solution for it without those resources. I want to turn back to Catherine. So we've talked a little bit about some of the challenges with access and benefit sharing, that it's not always possible to just take a wild species and put it in a new place and voila, develop a new market. But there is a lot of opportunity for countries that do have those wild that germplasm or those genetic resources available within their countries. And the project you described working with Arabica farmers is a great example. Can you just elaborate a little bit on how Uganda sees its genetic resources as a resource for supporting the livelihoods of farmers, and talk a little bit about where it's headed next? I think in one of our earlier conversations, we talked about the fact that actually a lot of European coffee drinkers are drinking Liberica mixed in with their robusta and don't know it. Will it become a market where we can get single origin Liberica from Uganda over the next couple of years? Do you think it'll stay as something that's sort of mixed in with robusta? Where do you think that will go?
Our goal is for Liberica to have its established market niche, because already it has shown potential. It's already been traded for over 40 years. Farmers have been selling this coffee, and the traders have been simply mixing it with robusta and sold outside Uganda. So that alone informs you that if this coffee has been sold for all this long and it's still being yearned for, what can we do as researchers to support these efforts? First of all, Arabica coffee, it as it is in that region, it stands out as being uniquely having superior cup qualities. Even cup qualities, with our preliminary results are showing that the cup quality of this Excelsa coffee is in between Arabica and robusta. Now, to streamline issues of access and benefit sharing, Uganda as a country has a national access and benefit sharing law, which is currently being revised, but already there are international instruments like the Nagoya Protocol and the Nagoya Protocol. We are obliged to follow and implement. So under those arrangements, we can be able to see how best Uganda as a country can lobby for its benefits as the center of origin for this excelsior coffee. There are opportunities like geographic indicators. I don't know whether we are familiar with such. So we are working with the farmers to see how in the long run we can tap into all those opportunities, not in a restrictive manner, but also to support other producers if they are interested in upscaling this and if their ecological conditions allow for this. But it all has to be under legally acceptable access and benefit sharing regimes.
Thank you.
Can I just...
Yeah.
Just because it's just following on from Catherine's point about scalability. So the project that Catherine presented on, and I showed half a slide on, one of the objectives of the project is to bring it to scale. Mm-hmm. So our target volume this year is 2,500 kilograms. Next year it's 5, 10. So that's the focus. We want to bring it to scale and for the benefit of farmers, because at the moment they're getting sub-robusta prices.
Gotcha.
For a coffee that sits in terms of its, let's say, average flavor quality, that's a terrible term, sitting somewhere between Arabica and robusta. Mm-hmm. So it should be getting a better price. And that's on offer during the tasting session. Please be kind on it.
We're going to actually follow up this afternoon in one of the discussion sessions with a deeper dive into this question of building markets and figuring out how do you create a new market for a wild species. So we'll talk a little bit more about that. Vern, did you want to add something there?
One more big picture point here, and I think that just to be a bit more summative as we move to a close, the question is, who is going to take control of this, or who is going to engage? And the opportunity here in this room and with Catherine on the phone is to bridge that awareness between the industry and the opportunity happening in producing countries so that you all are aware of what's possible. But we can't sit back in our armchairs and say, somebody else is going to deal with it. We have to take this on. This is our opportunity, and it's the challenge our industry is going to be facing over the coming decades. And there is a tremendous amount of opportunity here with experts like Sharada and Aaron who are ready and excited and willing to move this agenda forward and identify where there's this opportunity to bridge what biology has on offer, what nature has on offer, and what farmers are excited to produce, and what we as an industry want to procure and sell to our customers. So this is the opportunity, and we hope that this is just the jumping off point. For those of you, even small companies, this is not a big company issue. There was a question that came to us. It's not just huge companies that have this opportunity. Groups of smaller companies can get together and say, you're in the room, you're here with Aaron and Sharada, Catherine's on the line. You can talk about it and find out what's out there, what's possible, and what can you do to bring this kind of innovation forward to consumers. So I just wanted to leave with that.
I think that is a great place to wrap up.
Sure.